Hello, I am Marina, and in this video I am going to show you an example of the machine learning software Neural Designer applied to an engineering and industry issue. The topic of this example is the strength of high-performance concrete. Construction companies produce concrete with different proportions of each ingredient. We will build a model that will predict the strength of the concrete based on its materials and their measures. This will improve the quality of the concrete and reduce its cost. The first step is to download the data file from the Neural Designer website. We can open it and see that it has over 400 instances. The data file also contains 8 columns. These are the ingredients of the concrete: cement, water, and fine and coarse aggregates, but also blast furnace slag, fly ash, and Superplasticizer, because it is high performance. The last column is the target variable, which is the compressive strength of the concrete. Then we open Neural Designer. In the main tab, we have 3 options for creating a new project: an approximation model, a classification model, or a forecasting model. In this case, we want to predict the numerical value of the strength of the concrete, so we choose the approximation model. After creating the project, the first thing to do is import the dataset we have downloaded. Once it is imported, we have a preview of the data with a number of columns and instances. In the next table, we can see what type of data each variable is. Also, we must select the target variable, in our case, the compressive strength. Now, we will study our data to have a better understanding of it. One of the most important aspects is to calculate the column distributions. We have a histogram for each variable. The last one is for the compressive strength, and we can observe that it has a normal distribution. We can also check which variables have the greatest impact on the target variable by calculating the input-target correlations. In this case, the amount of cement is the most related to the strength of the concrete, followed by the amount of water. After analyzing the data, we can build a model to predict the target variable. For that, we must click on the Neural Network tab. There are certain default values for the perceptron layers, number of neurons, and activation functions. For now, we will leave it as it is. Let's create and visualize the neural network. This diagram means that we introduce 7 inputs, and the neural network gives 1 output. The next step is to train our model by searching for the parameters that will fit it to our specific data. We can choose from different types of error, regularization methods, and optimization algorithms. After training the neural network, we will get a graph that shows how the error decreases. We must also pay attention to the selection error, which is 0.18 for this example. Our model is better the closer this error is to 0. If we want to improve the performance of our neural network, we can proceed to the Model Selection tab. Using the neuron selection, we'll optimize the number of neurons that the model has in order to obtain better predictions. In this case, using 4 neurons is the optimal value. With it, the selection error decreases to 0.15. To see how well the neural network can predict the compressive strength of concrete, we will perform testing analysis. In approximation problems, the best way to visualize the model's performance is to make a linear regression analysis. This will plot the real value of the target variable against the predicted values. If the model was perfect, the regression line would have a slope value of 1 and an intercept of 0. In our case, even though it is not perfect, we have a good correlation coefficient of 0.9. Another testing method is visualizing the error histograms. We can see here the distribution of the error values to see whether most of them are close to 0. If we calculate the error statistics, we will see that the mean percent error is 7%. This means that our model predicts the compressive strength of concrete with an error of only 7%. Finally, we can go to the model deployment section and calculate specific outputs. We introduce the proportions for each ingredient of the concrete, and we will obtain the compressive strength that the model predicts for this case. This will reduce the cost of producing the concrete, because we will not need to use the trial and error method to achieve a certain strength. Another option is to plot the directional output. This will show us how the target variable depends on the inputs. The amount of water has been long known to be a factor in the strength of concrete. With this model, we can see that other ingredients also play a role in the strength. Increasing the amount of cement means a higher compressive strength, as well as the blast furnace slag or the fly ash. It is also possible to write the mathematical expression of the model or to export it to programming languages like Python or C. Thank you for watching. Hopefully, this tutorial helped you make the most of Neural Designer. Subscribe to our channel for more content on machine learning.